from this unit circle, imagine if I'm creating an angle in standard position. So I move it counterclockwise. So I suddenly stop. So there is a point of intersection here. That is the point of intersection of the terminal side and the unit circle. I name it as point A. So definitely it has coordinates x and y. This will also have an angle measure theta here. So if you are asked to find the measure of this theta, you know already that this theta is between 90-degree angle and 0 degree. So if you move again from standard position, you move here, then you have a terminal side here. This terminal side has, let's say this is point D, and this terminal side, this point, the terminal point here, so the angle is standard position. Let's try to represent the measure as beta here. Okay, and it is found on the second quadrant. Okay, so it means to say the measure of this, the angle measure from the terminal initial side to the terminal side, it is between 90 degrees and 180 degrees. Okay, so that is greater than 90 degrees. So if you move angle in standard position and you suddenly move counterclockwise again, stop here, quadrant 3, name this as point C. Then you can expect that there is a particular angle measurement, let's say that is alpha. The measure of this angle being formed counterclockwise in standard position is between 180 degrees to 270 degrees. Okay? And however, if you move counterclockwise again, so let's say you stop here. So there is a terminal point, let's say that is B. Then the measure is being represented by, let's say that is being represented by phi. Okay, so it means to say the measurement of the angle phi here is between 270 degrees to 360 degrees. Now, what if we are interested to know the angle measure formed from the x-axis to that of the terminal side? So here, we are interested to know this. And we observe that that is already an acute angle, right? And so with this, from x-axis to that terminal side here, okay, there is also an acute angle. Observing an angle formed up to the terminal side, acute angle as well, because that is greater than 0 degree, but less than 90 degrees, because this is already 90 degrees, right? And so with this, there is also an angle being formed here, from x-axis to that of the terminal side. That angle being formed from the x-axis to the terminal side is what we call the reference angles. The reference angle is a positive acute angle formed from the x-axis to the terminal side. And what is the implication of the reference angle? It gives us the idea that using the 30 degree, 60 degree, 90 degree angle, the 45, 45, 90 degree angle, we can solve for the coordinates of the points found on any of these quadrants. I have here illustrations, and the first angle that we're going to talk about is the angle that forms a 48 degrees. Okay? And 48 degrees is already considered to be the reference angle itself. Why? Because that is already an acute angle. So you have angle that is 48 degrees in measurement itself is the reference angle. Okay, take note of that. When the angle is found on the first quadrant, then the angle itself is a reference angle. Okay? But what about if we have this angle that measures 135 degrees, but the second angle forms 135 degrees, and that is in counterclockwise rotation and it is in the standard position, how do we able to get the reference angle of that? The reference angle is now formed here. From the x-axis, this will now represent the reference angle. And how can we get the measure of this? We know that half of a circle is 180 degrees when it comes to degree measurement. Okay? So 180 degrees minus 135 degrees is equal to 45 degrees. So it means to say the reference angle of 135 degree angle is 45 degrees. So you just need to remove 135 from 180 degrees and that's it. So when the given is 135 degrees, the reference angle is 45 degrees. So what is the clue? When you add these two, will give you 180 degrees. Okay, so that 45 degrees is the smallest acute angle formed here. Okay, so what about if we have a 210 degree angle? That is counterclockwise again. 210 degrees, so meaning to say you exceeded 180 degrees. Nilampasan mo 180 degrees. Okay, by how many degrees? That is 210 degrees minus 180 is 30 degrees. So meaning to say, if the angle measures 210 degrees, then its reference angle is 30 degrees. And the last, the angle that measures, let's say for example, I'm just trying to approximate, let's say the measure of the angle having a terminal side that lies on the fourth quadrant, let's say that is 340 degrees. So as if we are forming a one complete revolution here, right? So meaning to say there is a degree measure here that is 20 degrees. How did it happen? Because you are trying to complete a 360 degrees, so 340 degrees needs 20 degrees to form 360 degrees. So 340 degrees angle measurement, its reference angle is 20 degrees. From these examples, we will now create or generalize the rules in solving for the reference angles of each particular angle that lies on quadrant 1, 2, 3, and 4. But what if we have a negative angle? That is, the rotation is clockwise. Just like for example, we have negative 40 degrees. Remember that negative 40 degrees is just a representation of clockwise rotation. Let's say this is negative 40 degrees. And itself is an acute angle. Therefore, the reference angle is positive 40 degrees. Okay? So what about if we have an angle that is still formed clockwise, and let's say the angle is, the measure of the angle is, for example, 125 degrees, and that is a negative 125 degrees because the rotation is clockwise. Okay, now consider a clockwise rotation. So we have negative 125 degrees, and it is already found on quadrant 3. The terminal side is already found in quadrant 3. Let's say this is point E. Okay, so how do we get the reference angle of this particular angle? Remember that we can form here an angle from positive or from x-axis up to here. So how can we form 180 degrees? How much do we need to form 180 degrees from negative 125? So the reference angle of negative 125 degrees can be solved using this. 180 degrees minus 125 degrees. Okay? Because we're looking for this excess here. This is the reference angle, and that is equal to 55 degrees. When we add 125 degrees to 55 degrees, then we get 180 degrees. That is our intention here, okay? So negative 125 degrees clockwise rotation has a reference angle which is 55 degrees. But what if we have negative 365 degrees? And we know that one complete revolution in clockwise rotation is negative 360 degrees. So what is the excess measure of it? We have 5 degrees. That is the reference angle of negative 365. So how did we get 5 degrees? Remember that our rotation is clockwise in standard position, okay? This is negative 360 degrees, so there is 5 degrees excess here. This is 5 degrees. Because one complete revolution for a clockwise rotation is negative 360 degrees, okay? So there is an acute angle formed here. So what about if we have, let's say for example, negative 295 degrees, and what will be the reference angle of that? Negative 295 degrees, if we try to illustrate that, so it's almost here. It's negative 295 degrees. It is found on quadrant 1. Okay, so there is an acute angle formed here that represents the reference angle. And what is that? So how do we solve the reference angle of this negative 295 degrees? It can be solved using this. 360 degrees minus 295 degrees. We can use this immediately to get the positive value or the acute angle. Okay, so the answer is 65 degrees. Consider this point on the unit circle. Let's say this is point P. Therefore, it has coordinates x and y. Now, what is the implication of the reference angles here in finding for the coordinates of points on the unit circle? Also, what is the implication as well of the 30, 60, 90 degree angle and 45, 45, 90 degree angle? All angles that lie on the axis are considered to be quadrantal angles, just like 90 degrees, 180 degrees, 270, or if we have clockwise, negative 90 degrees, negative 270 degrees. These quadrantal angles do not have reference angles, okay? Even 0 degree angle or 0 radians, okay, are quadrantal angles and still do not have reference angles. So if we have 45 degrees here as a reference angle and the terminal point here is P, then we're looking for the coordinates here x, y. It is as simple as looking here. We know already that the side opposite 45 degree angle is square root of 2 over 2, and so also with the other. So therefore, the coordinates here are square root of 2 over 2 and square root of 2 over 2. Both are positive because we are in quadrant 1. But if we have another angle that it also have the same reference angle as the other, let's say the angle here formed is 135 degrees, which is also true because in here in our example, the reference angle of 135 degrees is 45. Then we expect that they have the same coordinates, square root of 2 over 2 and square root of 2 over 2. However, since it is found on quadrant 2, the x coordinate must be negative. Okay? The sign matters. So let's say for example there is an angle which is clockwise in rotation here, and the angle measurement is negative 135 degrees. Still, the reference angle is still 45 degrees here, so looks that way again. And since it is found on quadrant 3, let's say the point is point F, and the coordinates of the signs of the coordinates of point F are negative and negative. So since we are point F is on quadrant 3, then the coordinates are both negative. Okay, so we have negative square root of 2 over 2 and negative square root of 2 over 2. So if we have another point here, let's say this is point G and the rotation is clockwise, then the reference angle is the same, 45 degrees. The coordinates of this point G are positive is x, so we have square root of 2 over 2. Negative is y, so negative square root of 2 over 2. That is important, okay? Just always remember that they're always the same, especially that they have the same reference, but the signs are not the same. So let's say there is another terminal point, and that is, let's say, point M, and this is 30 degrees, 90 degrees, so this is automatically 60 degrees, okay? So if we look into here, the side opposite 30 degrees is 1/2, opposite 60 degrees is square root of 3/2. So 30 degrees, so this must be 1/2, and that will represent x, so that is 1/2. And y here is square root of 3/2. So it will still follow. If you move here, then you just need to change the sign. Now we need to understand the signs of x and y coordinates on each quadrant, okay? On quadrant 1, positive and positive. Here we have negative and positive. And in quadrant 3, negative and negative. Quadrant 4, we have positive for x and negative for y. Okay? Now, this 4 will guide us in determining the sign of sine, cosine, tangent, cotangent, cosecant, secant on each quadrant. Now, we need to understand the sign of each trigonometric function. So, with regards to coordinates, or where can we find it on particular quadrants? Okay? We know that sine function in the unit circle refers to y, and cosine refers to x. So we start from these two. So in quadrant 1, we know that cosine is positive. So here we have positive, and also in quadrant 4, positive and positive here. So it follows that the reciprocal of cosine, which is second function, will also do the same, positive and positive. For sine function, in quadrant 1 and quadrant 2, positive and positive. Okay, so we have positive, positive, and its reciprocal, that its cosecant function, will do the same, positive, positive. So the remaining will now be negative, negative. So it is. Now for tangent and cotangent, we just need to observe the sign of sine and cosine, because we know that tangent for a unit circle is y/x, and cotangent is x/y. Okay, so positive, positive, positive divided by positive is positive, so cotangent will follow the same. And negative divided by negative is positive, so this will also give us a positive tangent and cotangent values. Positive, negative, automatically negative. Negative, positive is negative. So these are the signs. Whenever we talk about the trigonometric functions, we just need to observe where can we find that angle and be able to identify now the values. So let's say there is an angle that measures 210 degrees. And there's a point here, let's say that is point R. We're going to find the coordinates of point R. So let's say there is an angle that is 210 degrees. And it is illustrated here, 210 degrees. It is found on quadrant 3. So we expect negative, negative as the signs of the coordinates. And the reference angle of 210 degrees, 180, okay, so there is 30 degrees added to 180 to form 210 degrees. So the reference angle is 30 degrees. Now 30 degrees, the side opposite 30 degrees is 1/2, remember that again. And this is automatically 60 degrees. The side opposite 60 degrees is the square root of 3/2. Therefore, that is when it comes to length. Okay, now when we talk about the coordinates, the x coordinate of point R is square root of 2/2, and that must be negative. And the coordinates of the y coordinate of point R is negative 1/2. So what does it mean by these two coordinates in solving for the 6 trigonometric functions? Now, the x coordinate that is negative square root of 3/2 and the y coordinate that is negative 1/2, remember, this x coordinate represents cosine. So we have cosine 210 degrees is equal to negative square root of 3/2. Okay? And sine 210 degrees is equal to negative 1/2. When we refer already to the coordinates. So what about tangent 210 degrees? And to tangent, for tangent, that is represented by y over x. And y is sine 210 degrees. And x is cosine 210 degrees. Substituting sine 210 degrees, which is negative 1/2, and then cosine 210 degrees is negative square root of 3 over 2. Negative and negative will give us positive, so we have 1 over square root of 3. Rationalize that. So tangent 210 degrees is square root of 3 over 3, and that is positive. Tangent 210 degrees is originally 1 over square root of 3. So it means to say, when we get cotangent 210 degrees, we just need to get the reciprocal of 1 over square root of 3. The answer is square root of 3. Okay? Now for cosine 210 degrees, we know that the reciprocal of cosine is secant function, and that is secant 210 degrees. So the reciprocal of negative square root of 3 over 2, that is 1 over negative square root of 3 over 2, will give us negative 2 over square root of 3. Rationalize that. So multiply both sides by square root of 3 over 3 will now give us negative 2 times square root of 3 is negative 2 square root of 3. Square root of 3 times square root of 3 is 3, and that is secant 210 degrees. Now for sine 210 degrees, its reciprocal identity is cosecant 210 degrees. So get the reciprocal, 1 over negative 1/2 is equal to negative 2. So that is a value of cosecant 210 degrees. These are the 6 trigonometric values when a particular angle forms 210 degrees, and the coordinates of the point R here will now guide us as well in finding for the other 4 remaining coordinates. Remember that this 210 degrees is angled in standard position, which is counterclockwise in rotation. If I create an angle that is coterminal to 210 degrees, the measure of this angle, clockwise rotation, is negative 150 degrees. This negative 150 degrees also share the same terminal side. That is why they are coterminal angles. It also has the same reference angle, and that is 30 degrees. Meaning to say, the same coordinates of a point R. Okay? We have negative square root of 3 over 2 as x and negative 1/2 for y. That is the implication of coterminal angles. All angles that are considered to be coterminal angles have the same coordinates. So it means to say that all coterminal angles will have the same coordinates and will surely provide the same 6 trigonometric values. So this negative 150 degrees and 210 degrees will share the same terminal side. We can now say that cosine 210 degrees is also equal to cosine negative 150 degrees, because negative 150 degrees and 210 degrees are coterminal angles. It also follows here that is also equal to sine negative 150 degrees. And also this tangent negative 150 degrees. This is also cosecant negative 150 degrees. Cotangent 210 degrees is also equal to cotangent negative 150 degrees. And also this secant 120 degrees is secant negative 150 degrees. So it means that if I rotate counterclockwise, that is 360 plus 210 degrees, and that is 360 degrees plus 110 degrees, and that is equal to 570 degrees as the measure of theta, then all values cosine 570 degrees, tangent, cotangent, cosecant, secant, sine are all the same as 210 degrees provided a while ago, together with negative 150 degrees.